Hello everybody, welcome to today's science lesson. Now both of your videos for wider curriculum this week are going to be linked to science, and they're going to be on our topic of forces, which we started last term and didn't quite get a chance to finish. It might be worth just spending a few minutes casting your mind back and reminding yourselves what we did. So to begin with, we started by identifying lots of different types of forces. We explored vocabulary linked to that and kind of grouped them into things like pushes and pulls, if you remember. The next lesson, we explored the difference between weight and mass, weight being the force of gravity and mass being how much stuff something had. We explored that using the Newton meters. And then we had a lesson where we explored air resistance. So again, air resistance was a force acting against things moving through the air, and we explored that with our parachute investigation, where we timed different size parachutes getting down to the floor. So using that knowledge, and particularly what I've just said about air resistance, what is water resistance? Can we come up with a definition? If you pause me and then come back. Okay, so water resistance is simply a force acting against things moving through water. So as it's acting against it, it tends to slow things down. All right. So if you think about we've got a picture here. If you guys have ever walked through water on the beach or in a swimming pool, whatever, what does it feel like? It kind of feels like you're having to push loads more, isn't it? You're having to put more effort, more energy into doing so. Okay, so water resistance can slow things down. All right. Now, when might water resistance actually help us, do you think? Is there something where it actually makes something safer or easier? Have a little think, write them down. I'd love to know your suggestions. Okay. Now, before I move on to the next thing, I want to draw your attention to this star word here. It's going to be really important for our exploring of the uses of water resistance here. Buoyancy. Okay, quite a fun one to say, buoyancy. Sounds quite bouncy. What can you remember what this word means? This is one of the ones I think we found trickiest in that first lesson. What does it actually mean? Okay, well, if you're not sure, I want you to maybe either write this down or do something so you remember. Buoyancy is a force acting up against something that is either submerged or partly submerged. That means kind of partly in the water. Okay, so it's an upwards force in the water acting against something that's sitting on top of it. All right, and I'm going to explore that a little bit more in just a bit. Okay, right. So for today's lesson, we have a very famous scientist that we're going to link our learning to. Okay, and his name was Archimedes, and I think you can tell that he was around a very long time ago from this most up-to-date picture of him. Okay, so what I want you to do, this here is a link. What I'm going to do is I'm going to put it onto our website. Before we go any further, it's about 5 minutes long and it is an investigation. It's got Dick and Dom, you might remember them. It's an investigation and a bit of research into who Archimedes actually was. It's quite funny. You might enjoy it. So if you want to pause me here, watch that and find out a little bit more about Archimedes, and then come back and we'll talk a bit about what the video showed you. Okay. So, as it said, Archimedes was an incredibly famous Greek scientist, and I guess one of the things he was most famous for, other than just being in the bath, was his principle of buoyancy. Okay, and he discovered this by being in a bath. He noticed that when he got in the bath, the water rose up around him. In some ways, it flowed out of the bath, and it led him to discover that when you put something in water, we have the force of buoyancy acting against it, as we just spoke about. And what happens is that matches. So the weight of the object, okay, so remember weight is the force of gravity, how strong the pull of gravity is. The weight of the object matches the buoyancy, the force against it, and the way that that water rises. Okay, so the water is displaced. Displaced is a fancy word for moved. Okay, it's taken from one place to another. So if you put something in, the water moves around it. Okay, and they are equal. The weight of the object is equal to the buoyancy, the water displaced by the weight of the object. Okay, so don't worry, this is it's quite a tricky concept to get your heads around. So don't worry if you're not quite sure on it. What we thought is we'd give you an opportunity to explore this hands-on. Okay, so if I show you this, now the sheet with all of the instructions for this is on our website, and I'm hoping you guys should have the things that you need for it at home. So you need a measuring jug, hopefully with the measurements. You probably find that in the kitchen. Interlocking cubes, that could be Lego, sticker bricks, whatever you've got. If you've got anything that can kind of stick together and you can put in different shapes, great. Pencils and water. Okay, so basically read the instructions. Essentially, you are experimenting using different amounts of blocks and blocks in different shapes, putting them in the jug with water and looking at what happens to those water levels. Okay, so have a think about it. Maybe go away and have a go with that. There is, if you wanted to record your results, there is kind of like a template of the jug included on the worksheet. And a few questions for you to be thinking about while you're doing it is, what happens? So if you joined all of your bricks together in one tower to kind of make it long and thin, what happens there? What about if you kind of made a square, so a wider shape with them? What about if you did something like that? And which shape is more streamlined? I'm going to talk a bit about that word in a minute, but just have an explore, see what you think. If you're not able to do that for any reason, if you haven't got the cubes or anything, you could just try it out with a jug, water, and any objects that you've got. Okay, and then we'll come back together. Okay, so hopefully you had a chance of that and you were able to see how the water rose. Remember, the basics are, if an object is put into water, the gravity on that object, there'll be an equal force, the buoyancy press going up against that object. And what that causes is it causes the water to rise or be displaced around it. Okay, so this word streamlined, can you guys think of what it means? You might have thought about it. I think when I hear streamlined, I think about the design of aeroplanes or perhaps ships or even things like bicycles and, the way cyclists sit on a bicycle for it. Streamlined basically means how the shape of something has very little resistance. It causes very little resistance in air or water. Okay, so basically, kind of when we think about streamlined, we often think about things that are kind of, again, if you think about an aeroplane, they're quite long and thin. So the less kind of surface area they've got, the less air or water resistance acts on them. Okay, if you think about, for example, if you had a big kind of boxy lorry, there's lots of surface area for that wind or water, it wouldn't be in water, but wind to act against. Okay, whereas if you think about the way things are designed to kind of be more sleek and streamlined, if you think about perhaps the front of modern day trains, they're often designed in a way that causes much less air or water resistance against them. Okay, so that might be something you want to go and investigate. Again, if I were thinking about in the water, I might think about the shape of boats. Okay, again, think about how swimmers in like the Olympics and stuff, think about kind of how they swim. They try and make their body as kind of streamlined as possible. Okay, or you've got what's it called? What am I thinking of? Like a dolphin or something like that. If you've got like a dolphin, think about the shape of them and how it helps them kind of move through the water quicker. Okay, so your final challenge, hopefully you've learned a little bit about Archimedes and his theory. You've had a go at testing it using Lego or whatever you had in your house. Now, what we want you to do is have a go at designing a boat that has the following features. Okay. It needs to be able to float. So you need to think about the weight of it. If it's got too much weight, if gravity is acting too strongly on it, it will pull it down and therefore it won't float on top of the water. It needs to be made from recycled materials, okay? And it needs to be streamlined. All right, now there is a sheet for you to design this on, and we've asked you to label all of the features using the scientific vocabulary from this lesson. buoyancy, streamlined, all of those kinds of things. If you remember last week we said to you, if you've got any recycling, hold on to it, because you might be able to do a bit of building on Monday with it. Once you've designed it on paper, if you want to, and your adults are happy for you to, have a go at building it, maybe even testing it, filming yourselves testing it, we'd love to see it. Okay, so water resistance, Archimedes and his theory, how that works, the concept of things being streamlined and being able to float, buoyancy, and then having a go at designing your boat. All right, hope that makes sense. On Wednesday, we're going to have another science lesson all about cracking contraptions. Can't wait to see you then. Take it easy, guys.